Section P3, additional practice. This section talks about rational exponents and radicals. Rational exponents and radicals. Of course, when we have or asked to work with a to the n equals b, n is a positive integer, then a is the nth root of b. That's what it means. So if you have like a squared equals b, then we say a is the square root of b. So if we are asked to find 36 to the 1/2, what's the number here? If you multiply by itself twice gives you 36, it's 6. If we are asked 49 to the 1/2, what's the number if you multiply itself 2 times gives you 49, is 7. Okay. The same thing applies for higher exponents. Okay, so if we have in general, if n is a positive integer and a is positive, then a to the 1 over n is a positive. It's called positive real nth root of a, and it's called the principal nth root of a. So it's the nth root of a. That's what it is. That's what it stands for. So if we are asked to find 8 to the 1/3, so this is the third root of 8. Means what's the number if you multiply by itself 3 times? 3 times gives you 8. It's 2, because 2 times 2 times 2 is 8. Same thing applies for -8 to the 1/3. What's the number if you multiply by itself 3 times gives you -8? That's a -2. How about -16 to the 1/4? What's the number if you multiply by itself 4 times? 4 times gives you -16. That's a -2. Since if you take -2 multiply by itself 4 times, okay, actually positive, it's a +2. 4 times gives you 16. So in the rational exponents, when we talk about rational exponents, what we have here, if we have m and n are positive integers, then a to the m over n can be rewritten as the nth root of a all to the m, provided that a to the 1 over n is real. Provided it's real. So let's say we look at an example on this. Say we have 8 to the 2/3. So the way we work this out, 8 1/3 to the second power. And we just found out 8 to the 1/3. What is it? 8 to the 1/3 was 2 to the second, so the answer would be 4. How about if the exponent is negative? Say 27 to the -2/3. Based on the properties from the previous section, we rewrite this as 1 over 27 to the 2/3 first. Then 27 1/3 square. But 27 to the 1/3 is 3 square. That's 1/9. 1/9. We can look at more examples. Say 16 to the negative 5/4. Of course, you can pause the video and always try the problem. Pause the video and try the problem. Then here we can first get rid of the negative exponent. You do 1 over that. Then you can write this 16 to the 1/4 all to the 5th power. 16 to the 1/4 all to the 5th power. Then the one inside the parentheses, what's 16 to the 1/4? The 4th root, so the 4th root of 16. So what's the number if you multiply by itself? 4 times gives you 16 is 2. Then 2 times 2 times 2, 5 times is 32. So 1 over 32. So they all go the same way, how we simplify them. Now they can ask us to simplify different kinds of exponents. Say x to the 2/3 times x to the 10/3, let's say, or x to the 8th, y to the 1/3, all to the 4th power, or let's say 1/4 power. So let's see what we get. For the first one, this gives me x 2/3 plus 10/3 because they have the same base. We add the exponents. Since they have the same denominator, we can combine them. That gives me 12/3, which is x to the 4th. That's the best we can simplify. Next one. We multiply 8 times 1/4 times y, 1/3 times 1/4. That gives us x squared times y to 1 over 12. That's all we can do. Another example. A to the 1/4 times a to the 1/3 all to the 12th power. Pause the video and try it. What do we do with this one? We multiply the exponents. 1/4 times 12 times 1/3 times 12. That's one way to do it. Here I got 3 and here I got 4. So that would give us a to the 7th power. Because they have the same base, I added the exponents. Next, we can look at what we call radical notation. In radical notation, what we have, the a to the 1 over n can be written as a, the nth root of a, like that. So the 1 goes inside and a outside, and outside 1 inside. So this is the radical notation of this. This a is called radicand, and the n is called the index. It's called the index of the radical. So keep in mind when we do something like this, say this is read as radical 5 or square root of 5. Square root of 5. There's a 2 there, hidden 2. So this is the same as 5 to the 1/2. Square root of 5. Now, if we do negative square root of 5 or negative 9, the 4th root, or the 8th root of negative 1, those are not real numbers. Do not exist in real numbers. You can have negative, so we can have a negative number under the radical when the index is even. When the index is even, so there's a hidden 2 there. so we can't have negative numbers, as you can see, under the radical sign when the index is even. So we can simplify to practice more on this. Simplify, say the square root of 81, or the cubic root of negative 27, or the fourth root of 81 over 16. So what's the square root of 81? What's the number if you multiply by itself twice gives you 81? It's 9. What's the number here? The index is odd, so it's okay. What's the number if you multiply by itself 3 times gives you negative 27? Gives you negative 27 is negative 3. So for this one, what's the number if you multiply by itself 4 times gives you 81 over 16? That would be 3 over 4. 3 times 3, 9. No, 3 over 2, sorry. 3 over 2. Because 3 halves times 3 halves times 3 halves 4 times gives us 81 over 16. Another thing to recall is if we have a m over n in general, it doesn't have to be 1, we can write this as a index n and m on the top, or m can go inside like that. So we can ask students to write each in radical notation. Say 5 to the 2/3, or 5x to 4/5. So if you look at the formula that I just gave you, so how does that go? You put the 5, the top one goes inside, the 3 goes outside, and that gives us the cubic root of 25. For the next one, we can write it as 5x, 4 inside, 5 outside. 5 outside. And then of course you can simplify this. 5 times 5 times 5 times 5, 625, and x to the 4th. Another example, 8 times x plus 2 to negative 1/3. Put a negative sign there. Pause the video, try it. This first thing is the negative. The negative is only associated with this, not the 8. So we keep the 8 there, we bring that down. Then this becomes, you put a radical sign. The 1 goes inside and the 3 outside. So that's the answer. 8 over the cubic root of x plus 2. 8 over the cubic root of x plus 2. Next, if we have, this is called the product rule here. The more than one thing under the nth root, this is the nth root of a times the nth root of b. So you can split it. That's called the product rule for radicals. And if we have a over b, you can do the nth root of a over the nth root of b, provided b is not 0. And how do we apply them? For example, if I want to simplify, let's say 5 over 64. Something simple like this. Or the cubic root of negative 8m to the 12. So the first one, you do the square root of the top, square root of the bottom one. So that would give me square root of 5 over 8. Done. For the next one, we do the cubic root of the first one times the cubic root of the second one. For this one, we know it's -2. For this one, m, you can put the 12 out, or you can do 12 over 3. So that would give 2m to the fourth. 2m to the fourth. We can do more operations with radicals. Let's say they ask us to simplify the square root of 49 minus the square root of 5. To do that, we look at 49. Oh, it's 7, but the 5, nothing can be done. If I change 49 to 45 minus the square root of 5, then I can't, there's no number you can multiply it by itself to get 5 or 45. But what can I do with 45? With 45, we can write it as 5 times 9, where 9 is a perfect square. So the 9 comes out as a 3 square root of 5 minus square root of 5. So now 3 minus 1 is 2 square root of 5. 2 square root of 5. Another thing to do, another example, 2 square root of 28 or 3 square root of 28 minus 7 square root of 7 plus, come up with a good example. How about the square root of 63? So let's see, what can we do? Pause the video, try it. We need to write the numbers in a way that one of them is a perfect square. One of them is a perfect square. So the 28 you can write as 4 times 7, because 4 is a perfect square. Keep this the same. 63 is also can be written as 9 times 7. So what do we get out? This comes out as a 2. 2 times 3, 6 root 7. This stays the same. 3 root 7. Now they all have the same square root. So all we have to do is this minus this plus this. That's a -1 plus 3 is 2. 2 root 7. We call them like terms. We combine them. We combine them. Sometimes they give us a different kind of questions to combine. Say, while working with this kind of radicals, not all of them matches. So let's say let's say 8 root 2 minus the square root of 27 plus the square root of 50 minus 7 square root of 3. The first one stays the same. This one is 9 times 3. This is 25 times 2. And this stays the same. Nothing can be done to this, but this becomes 3 square root of 3. This is 5 square root of 2, and this stays the same. So this and this, 13 square root of 2. This and this, minus 10 square root of 3. Other kinds of operations, how about if we do multiplication? 2 square root of 3 times 5 square root of 2. -3 square root of 6, 2 square root of 6. So for this one, we multiply the outer numbers. This times this is 10. Square root 3 times 2 is 6. So that's all we can do. Next one, we again multiply the outer numbers with each other. -6. 6 times 6, 36. But the square root of 36 is 6. So that gives us -36. How about 5 square root of 2a times 3 square root of, again, 2a. also we're going to do 2 square root of 3 all square. And we're going to do square root of 20x cubed minus the square root of 45x cubed. What do we get for this one? We multiply the outer ones, 15 square root of 2a by 2a, 4a square. But the 4a square goes out as 2a. So that would give us 30a. 30a. Next one. We do the square the 2 and square the radical. So this is 4. When you square the radical sign, the square root of 3 is always 3. So that would give us 12. Next one, this is 4 times 5, and x cubed, you can write it x squared and x, because the x squared is going to come outside as an x, assume x positive. Same thing here, 45 is 9 times 5, and the x, that one is x squared times x. The 4 comes outside as a 2, the x squared comes out as an x, that will leave 5x, minus the 9 comes outside as a 3, the x squared is x, that will leave 5x. Now, they have like terms, so all we have to do 2x minus 3x is negative x square root of 5x. Negative x square root of 5x.